Thanks everyone for joining today's webinar on AI-powered real-time data pipelines with Timeplus. My name is Sarwar Bhuiyan and I'm a field CTO here at Timeplus. So today we have a very interesting and exciting agenda prep for you. I'm joined by Gang Tao, CTO of Timeplus, and Chen, Chief Architect. So we'd like to talk about two things in general. So one is about our thinking of AI features and as it relates to data engineering and where Timeplus fits into this. There's a lot of development right now going on in the AI world, whether it is AI to help with software development or data engineering, or whether it's actually leveraging AI in more kind of like business facing or producing business facing solutions. So Gang will run us through a number of AI features that we've been thinking about. We have two very exciting demos prepared for you. And at the end, we will ask Ken to walk us through what is in development right now, what we've created in April, and what is upcoming in Timeplus. Before we start on the AI-related features, just a quick walkthrough of Timeplus. So Timeplus is a unified SQL-based streaming platform known for its performance and efficiency. It supports both stateful and stateless stream processing, as well as historical data analysis. It's used in many different applications, such as data pipeline, analytical queries, streaming analytics, streaming ETL, alerting. And we're actually proud that it's used in many different industries, including Fortune 1000 fintech companies, electric vehicle companies. We have some in the gaming world and e-commerce.
Thanks, Sarwar. So yeah, first, let me quick talk about why AI. So we are rethinking the data engineer with AI at the core level, because in the past few months, we are developing these AI features in Timeplus. So we embracing an AI power real-time always-on approach for the data pipeline creation that automate everything, so make data engineers scalable, sustainable, and smart, right? So there's some value behind this. For example, first is, of course, is efficiency. The AI is still super efficient, so it can greatly save your time, and so you don't need spend all your time on creating those pipelines, but more like focusing on the result, right? Also, in the past, like AI has in the past, this kind of data pipeline, data engineering stuff can only be done by those data scientists, data engineers, and now actually even the non-technical persons, they can leverage AI. They just focusing on what they want, and they can do even without deep SQL knowledge. Even SQL is not so hard, but still you need to learn how to use SQL. But by assist by AI, you actually can a lot of non-technical person can do that. And also like those the demo I'm going to show today for those change data pipeline actually is still quite complex if you want to infer the schema, if you want to create the extraction logic, right? So the AI can greatly reduce the overhead in this case. So that's why we talk about like in the real customer case, actually they're maintaining like hundred of or even thousand of pipelines. In Timeplus, it's just a material view that's extracting data, right? So, but it's hard to develop and maintain, right? So with AI, we actually can reduce the cost, complexity, and make it, scalable. So that's why AI. And in the follow-up, I'm going to make two demos. And the first demo is about the real-time video analytics, right? So you can see, and in today's visioning model is actually quite powerful. So it can be used in a lot of different domains, like a security domain, you want to detect intrusions, or in the safety domain, you want to detect that unsafety behaviors, or even in the healthcare, right? You want to check some like this patient file event, you want to take actions immediately. So the video the vision model is really powerful, but in most of the case only detect only get those information is not enough, right? You need to analysis those data, and you need to make decisions and take actions, right? So I think Timeplus is a good component that can complete your solutions. That when you get all this information extracted from the video data, you can do immediately actions based on the decision your analysis result, or you can do the real-time monitor on these data, right? So this is the demo I'm going to show you today about how we build a real-time video analytics. So the input is just any video data, like a live stream or recording or whatever. And there are two components. One is the inference server, and the other is the analytics server. The inference server is just a Python-based, running two vision models. One is like a YOLO 8-based object detector to check what's in a video. And also there's a behavior detector, like a violence detector. It's another vision model that detect whether there's some violent behavior inside the video frames. And then, inference server will collect all this, extract all the information, and send the JSON data to a Timeplus stream. And then with this Timeplus stream, we actually get all the extract the data from the AI models, and then we can do the analysis and monitor it in the real time. Okay, let me go to the real demo for this one. So my demo is running in a Docker. So for this video analytics one, you can see actually the two servers. One is the inference server here, and the other is just Timeplus. So in the Timeplus, actually, the inference server is actually reading a data, processing the data from a video. So if you take a look at this video stream log, it's actually getting all the video data there. So what is that video, right? Let me take a look at I create this video analytic dashboard. You can see actually this is from a trailer of the latest movie. It's not there yet. It's will be 2025, the new movie of the truth world, I think. And you can see we actually the two model is grabbing data from the AI model is running under the hood and send data to Timeplus. You can see there's all the extracted object, the detect object, the person, cup, bottle, and it's actually running in real time. Once the data has been detected, we do a 5-second aggregation here to tell you what's happening in the past 5 seconds, right? And at the same time, we have another analysis on the violence behavior. So you can see it's actually an aggregation on the 5 second of the video. You can see if there was a gun there, so the model think it is dangerous, so it gives some violence score here, and it's really in the real time because you didn't even catch the frame, but the on the hood the AI did that, but still you need a tool like a Timeplus can do the aggregation and show you what's happening, right? This is why you still need beside this AI model, and Timeplus can help you to analyze your data, monitor what's happening, and give you some insight. Right? Okay, that's the demo. I'm going back to the slides.
Just to add here that the output does not just have to be shown on a dashboard to human users, but the results of the streaming analytics can also be consumed by other software to take a mitigating action or something like that, an alert, right?
Right. Okay, so this give you some more information. Like this is the video data metrics we extracted from the inference server. It actually three part: the timestamp. We have the violence classification result. This is from one of the model, the violence detect model. And there's a detect object. It's another array of object. So it's from the YOLO 8, the object detect model. So actually the inference server will just collect all the information into a JSON, and this data will be sending to Timeplus, the stream. And in the dashboard, we actually run the query like this. This is the real-time analytic query we're running under the hood in the dashboard. We do array drawing with array JSON array extraction. So that means we can flatten the object in an array and do some and extract the what's the name of the object, and then we do a like a 5-second hopping window to do the aggregation. So then we know in the past 5 seconds what are those objects we detect from the frame, right? Similar for the violence score, we do a real-time streaming query to do the monitoring. Okay, that's the first demo about the real-time video analytics. And this is the main demo I'm going to show today, and it's even more exciting. It's about the how at Timeplus we leverage the agentic AI under the hood to create the data pipeline for you, right? So this is the demo architecture I'm going to show you today. First, I have two application database. One is Postgres, the other is MongoDB. So we have a data simulator that generating change data, and insert data into this production database. And then we are using the Debinism connector running on a Red Panda, which is the Kafka, right, to get all the change data. So there's three topics, two from Postgres tables and one from Mongo tables, Mongo collections, right? And then actually, with this change data, we want to extract all the customer or all the business values. So we are in Timeplus, what we do is by creating this data pipeline. So the external stream will read data from the Kafka topics, and the materials view will do the logic to extract the information from the external stream, and then we want to save the result to like for example S3. Of course, we do support different source and sink. For example, you can save data to database like Postgres or ClickHouse, or you want to save to like a data lake S3, save to Iceberg or another external stream. Under the hood, how we implement it is like powered by the AI. Like AI is our engine here. So we do have some agent. The pipeline agent is actually the pipeline agent is powered by the large language model. It can be your local model like running Olama, or it can be your cloud model like OpenAI or Gemini. Uh, the agent will smartly decide how to create this pipeline by inference the schemas, building the extraction logic, building the target stream. And also, what I'm going to show you today is how we can do this not by UI, but going with the AI Copilot. In this case, I'm running a cloud desktop because we implement this Timeplus MCP server by we put all these agent and like Kafka tools as part of this MCP functions to calling. So that means user doesn't just create the pipeline in the UI, but the user can do it in a by talk with your AI agent, right? That's a very interesting one. So by doing so, actually, you don't need to write any of the SQL, because writing SQL, like I mentioned, sometimes not every users have those knowledge. So you don't need to worry about your SQL skills. So there's no code, and it's simply you don't handle the complexity, and AI will handle the tedious work of pipeline building. So, and the structured data, whatever it's Mongo unstructured data or Postgres structured data, the AI can help you to build the extraction logic. And then that means the whole, even you don't have a quite lot of knowledge about this pipeline or the source data. you can easily create this pipeline, right? So let me go with the demo now. Our target is move our change data from CDC, Debian, from MongoDB and Postgres to my S3. Here is my S3 running as my main IO, and there's a bucket called Timeplus, and nothing is there yet. In the Debian, we can see we can show if there's data. Let's show the topics. So there are several topics, and let's see, we want to check what's the data on this topic. So for example, for this customer, from the latest offset, we can see some new data is being generated and sent to the Debian is collecting all the change data. So what I'm going to do is we are using some AI agent to create the whole pipeline that extract the data. So let's start with cloud. Let's have a new chart here. By talking with AI, we actually can do pipeline creation in an interactive conversational way. Say what are those Kafka topics, and the cloud desktop will try to list all the Kafka topics by calling these tools, list Kafka topics, and then we get, this is a much better user experience compared using the CRI tools because it's well formatted, highlight with syntax, so we know. So our target is to extract the data from this customer topic. So maybe we can show me one sample event from topic. So by doing so, we're actually doing the preview. So what's inside this topic? So we show, okay, there's a data like this. So the actually it's a Debian payload, and the after means a new data, new customer has been created with this specific customer ID, name, email, something, and there's some explanation from the AI. So looks good. So please help me create Debian data extraction pipeline and save data to S3 using our external Timeplus external table. So by sending this command, actually AI will leverage the different tools, like explore the topic to get the sample data, and also it will call the get the S3 configurations because we are asking to send data to S3, and then it's actually generating the whole pipeline for me by there's an agent running under the hood to analysis the source data and generating the extraction logic, and also inference what necessary schema is required. So now the pipeline has been created. Let's take a look at what it is. So this artifact is actually the whole pipeline creation sequence. User don't need to write those sequence because the AI will help us to write all the sequence here. There are some updates we can do. The first I need, because I didn't tell the AI what is the broker address. He just used broker, but actually it should be red panda, right? So because in my Docker it should be red panda. Use red panda here. So I'm asking AI that we should use red panda as our broker host. The external table looks good. It extracts all the required fields we need. And for the extraction logic, But the write to, maybe I don't want to write to a specific customer folder. Instead, I want to use customer, like use data customer.json as my write to file name. I just update the file name because this is what we want the AI I want the AI, pipeline to use. So and that looks good, and we can create this pipeline now. I think that's mostly human co-work with AI. AI is a co-pilot. So we do the update. We review the pipeline and say, looks good. And let's create this in Timeplus. So, and let me close this one. We can go open the Timeplus UI at the same time to see how this resource been created. It's the MCP, the cloud desktop is asking me to run whether we want to run SQL. Yes, we want it to run the SQL to create the resources. So the first one is to create this external stream, and second one is the external tables. If we refresh, we should see external stream and external table has been created. And lastly, it's creating the materials view, which is the extraction logic. Everything looks good. Okay, everything's created. And if we take a look at what's here, so if we query the external stream, it's actually getting all the raw data, the raw deposition change data. And if we go to the check the materials view, if we query, it's actually query the S3 as well. You can see all the data has been written to S3. We can query it as well. So if we go to the my min IO, if we refresh, you can see there's a data folder and all the customer JSON has been generated. If we can download one of them to see what's that. So if we take a look at this one, you can open using text edit. You see all the customer data has been extracted and saved to the target. Running as expected, it should calling those MCP tools to create the pipeline, and even some of the MongoDB one is it's actually a very unstructured data, and actually AI can help generate this the complex schema and generate very sophisticated extraction logic here. So our vision is to build this AI native pipeline features. It doesn't necessarily to be running in a chat interface, but you can see generally the pipeline contains the input data, data transformation, and output data. And for each stage, actually AI can help us do, like for the input stage, AI can help us to, the agent can explore the data, understand what's the event, and doing the analysis and enrichment, like build extraction logic, detect anomalies, filter sensitive data. And also for the output data, AI can help us infer the schema and check the data format and automatically create the destination configurations. So that means the AI can not only, even without this chart-based conversation, we actually can greatly simplify how the pipeline is being created and being used. Okay, so that's my demo, and I'm hand over back to Sarwar for the rest of the agenda.
Thanks, Gang. So as we've seen, you can use like AI features to help with your productivity and kind of like knowledge management and onboarding as well. As an extension to that, that can be applied in a lot of different scenarios, right? Like monitoring or debugging your pipelines, maybe even having like non-technical users interact with your streams and streaming analytics, which is quite a bit of a threshold today. So let's move on to the next part of our agenda, which is talking about the Timeplus updates. So Ken, if you want to take it away.
Yeah, thank you, Sarwar, and thank you, Gang. Yeah, so for the product side, we have lots of updates in April. So in March, we have a big stuff like elastic computation node. So you can scale out the cluster very easily if you like to have more computation power. So for example, if you like to run more than 1,000 or tens of thousands of materials view, you can do that right now. And also we have auto scaling materials view and other stuff. So in April, and next one. In April, we have even more updates. This is all of the updates are from our customers ask. So number one is basically pipeline evolution. This is something really big. It's like the pain point is like user like can update the schema and also materialize view. And previously, every single time you'd like to have a material view query update, we need to reprocess all of the data. This is really pain. And right now in April's updates, we solve these pain points. And also regarding the mutable streams online schema evolution, for example, user can add columns without breaking any kind of existing material view. The existing material view can still up and running, and you can update the schema. And also another one is which is frequently asked by our customer, which is the versioned mutable stream. So which is basically handle out of data in Zerlin. So for example, if you user right now can specify a version key of a version key column, and so online storage can honor the version columns during the merge, and the user do not worry about the out of order insert. And so another big stuff is basically the aggregation updates. So we have Coalesced mutable stream, which is basically solve that problem. We have different collectively a lot of materials we are updating the same row of the mutable stream. So we have another one which is super big, which is native JSON support. So right now user can have insert a big JSON, very complex JSON, and we will handle the JSON schema evolution automatically. Data letter queue is another one, which is super helpful for our end user for the troubleshooting. And for example, every single time there's a pointer event, we can log the event to the data letter queue. And also there are other integration like HTTP external stream, which can send the data to Splunk and also Elasticsearch. This is for the April's updates. Next one. So in May, we have more stuff regarding the system improvements. Regarding the materials view, for example, user can run the materials view by specifying the affinity. And also, we have the materials view auto rebalance. For example, you have a lot of materials view running in the cluster, and because we during the system reboot or other network stuff, one node running more material view, and there will be create imbalance in the cluster. And in May we will enhance that to automatically auto rebalance the material view on different computation nodes. And also we have the parameterized view. User can have a variable in the view, and they can fit the populate the parameterized variable during runtime instead of a static time. So, and also there will be more enhancement regarding the mutable stream, and regarding there's another very popular ask, which is logical kinetic sectionalization for the trace analysis. So there will be more like scheduling jobs and alerting, and also Python UDF in the macOS operating system support. Yeah, this is basically for the May updates. We will do next. If you have any question, please join our Slack, and also we have open source Timeplus program as well. Thank you.
Thanks, Ken.
Sarwar.
Yeah, so just watching for questions on the webinar chat. So there's a question about when can we expect some of these AI features in the Timeplus release?
Yeah, this is a typical one. We are thinking about have a preview release next month. So maybe user can try the preview product feature regarding the AI pipeline, and that they can solve a lot of pain points regarding the tedious field mapping and the extraction. Yeah, maybe next month hopefully we have some preview features.
For the AI pipeline generation, what kinds of challenges does it solve?
In one of my sample like this one, the really challenge is that actually customer has to maintain like 1,000 or even more such kind of pipeline, and writing those pipeline will be time consuming and tedious. Like even it's not some high tech, you can see the data structure could be complex, and the extraction logic can be very complex as well. Even if the developer can write this, it takes quite a lot of works to write such kind of pipeline. And with AI, actually, it can boost your production time by just automatically create everything for this. Still, sometimes the AI make some mistake, and the human has to do the correction for them. But most of the time, so consider you have 1,000 of them, maybe 90% of them has been automatically created and successfully. That will save you a huge amount of time.
Will the system do a dry run to validate the pipeline that's created?
The two part, right? One is it's actually just our agentic pipeline, right? We can add that to the pipeline to do the dry run and like self-correction. That all can be part of the agentic flow. And when you use such kind of AI chatbot, sometimes a smart chatbot like a cloud or other chatbot, they try to do that as well. They do some try run. If there's some error message, actually AI will try to update the SQL and to correct them. Yes, there will be some dry run under the hood.
What sort of end user experience do you hope to provide? Is it mostly a chat-based interface, or do you plan to guide them via wizards?
Like this one, yeah. Still, we probably for the pipeline builder, the main interface will still be some guidance of wizard, right? We guide users step by step, but it will greatly simplify the user experience by just few clicks, and because AI is taking over a lot of works. But still, there will be other exploration purpose chart boot, because sometimes if there's something you just want to explore and create some ad hoc pipeline, I think the chart interface will be there as well. But most likely we still want to use this like a wizard-driven AI UI for the user experience.
Thank you very much, Gang and Ken, for presenting our sneak preview of AI features and also the work going on into Timeplus. And thanks everybody for joining. We hope you got some ideas about how AI can help with data engineering and streaming analytics. And we look forward to launching this very soon. Thank you very much.
Thank you very much.
Thank you.